Welcome. Today, we're going to demystify something that's absolutely key for any Arduino project: how this little digital brain can actually sense and interact with the real, messy analog world all around us. So let's start with a really big question. Think about it. Our environment is full of gradients, right? Light gets dimmer, temperatures rise and fall, sounds get louder and softer. It's not just a series of ones and zeros. So how does a computer, which pretty much only thinks in black and white, even begin to understand that whole spectrum? Here's the best way to picture it. The digital world is like a simple light switch. It's either completely on or completely off. That's it. But the analog world, that's a dimmer dial. You've got this whole beautiful range of possibilities, from totally off to just a little bit dim to brilliantly bright, and every single tiny step in between. Okay, let's dive right in. We're going to start with how an Arduino takes in all this information, basically how it listens to what's happening in its analog surroundings. The magic happens with this command, analogRead. You can think of this as the Arduino's ear to the ground. It's designed to take a real-world signal, like a fluctuating voltage coming from a gas sensor, and translate it into a number that our program can actually understand and work with. So here's how it works step by step. First, a sensor reacts to something in the environment and sends out a voltage somewhere between 0 and 5 volts. That voltage goes into one of the Arduino's analog input pins. Then, a little chip inside, the analog-to-digital converter, does its thing. It converts that physical signal into a number your code can use, a value anywhere from 0 all the way up to 1023. Now, I know what you might be thinking. That range, 0 to 1023, it seems a little random, right? Why not something clean, like 0 to 100 or 0 to 1000? Where in the world does that specific number come from? Well, the answer is in the hardware itself. Specifically, it's a little component inside the Arduino's main chip called the 10-bit analog-to-digital converter, or ADC for short. So here's the key. 10-bit means that this converter can recognize 2 to the power of 10 distinct levels. Do the math, and that gives us 1024 unique steps of resolution. And since computers always love to start counting from 0, our range becomes 0 for the lowest possible value, all the way up to 1023 for the absolute highest. All right, so that's how it listens. Now let's flip to the other side of the coin. How can the Arduino speak back to the world? How does it create an output that acts like an analog signal? For this, we've got another command, analogWrite. This is how you tell your Arduino to do more than just turn stuff completely on or completely off. It's how you can precisely control the brightness of an LED or maybe make a motor spin faster or slower. But here's a super important detail you absolutely need to know. analogWrite doesn't use those analog input pins. Nope, it only works on very specific digital pins, the ones marked with that little squiggly line, the tilde. These special pins can do something called Pulse Width Modulation, or PWM. It's this really clever trick where the pin just turns on and off incredibly fast to create the illusion of a variable voltage. And hey, notice this, the value range is different too. When we're reading, we get that 10-bit precision, that big 0 to 1023 range. But when we're writing, it's only 8-bit. That means our output control has 256 steps, from 0 to 255. So why the difference? Well, it's just a classic engineering trade-off. You want super high precision for your sensors, but for a lot of outputs like dimming an LED, 256 steps is way more than enough for our eyes to see a smooth fade. Using 8-bit for output is just more efficient for the microcontroller. Pretty smart, right? This table really lays it all out side by side. You've got the function, its job, which pins it uses, and that really important difference in the value range. analogRead is for input, analogWrite is for output. Simple as that. All right, theory is great, but let's see what this actually looks like in real working code. You know, it's honestly this simple. To read a sensor you've got hooked up to pin A0, you just call analogRead A0. And then you store that result, that number between 0 and 123, in a variable. Here we've just called it sensor value. And now, when we watch that variable, we could see it change in real time. So in normal clean air, our sensor might give us a reading around, say, 369. But if it detects some gas, that value is going to jump up, maybe to 450, and that's how our program knows that the environment has changed. Now let's look at output. This single line of code tells the Arduino to send a signal out of pin 6, which, remember, is one of those special PWM pins with a value of 100. So this LED won't be at full blast, but it's not going to be off either. It'll be somewhere nicely in the middle. And we can get super precise control just by changing that number. A value of 50 would make the LED pretty dim. A value of 100, like we had in the code, gives us a nice medium brightness. And if you want to crank it up to the absolute max, you send it the top value in that range, 255. So, after all that, what are the most important things you need to remember? Let's do a quick recap. Let's lock this in. At its core, it really just comes down to this. Analog read is for high precision listening on those A pins. Analog write is for speaking or creating an effect on those special digital PWM pins. Just keep those different jobs, pins, and value ranges straight in your head, and you'll be golden. Oh, and here's a little pro tip for you, something that'll definitely save you a headache down the road. You know how with regular digital pins, you always have to use pinMode in your setup code to tell the Arduino if it's an input or an output? Well, get this. When you use analogRead or analogWrite, you can totally forget about that. The Arduino software is smart enough to configure the pin for you automatically, right behind the scenes. So yeah, that's one less line of code to worry about. And that's really it. You now have the fundamental tools to make your Arduino sense all the subtle changes in the world around it and to control your outputs with real nuance. So the only question left is, what awesome project are you going to build first?